So not all polynomial equations will be quadratic in form. So far, that's what we've dealt with. But you guys know how to factor things that aren't quadratic, so we should be able to solve things that aren't quadratic. The same steps follow. We still want to get things in standard form, factor, set each factor equal to 0, and check. So, first step, let's get these into standard form. To do that, I will subtract x squared and 6x from both sides. So to get this into standard form, I will have x cubed minus x squared minus 6x equals 0. And now I will factor this. Our strategy when we had a cubic function was either to factor by grouping, which isn't possible if we only have 3 terms, or factor out a greatest common factor, which is what we have here. So I'll have x times x squared minus x minus 6 equals 0. And now I'm interested in factoring the trinomial inside the parentheses. The x will stay out front. I'm looking for factors of negative 6 that add to negative 1. And that should be a negative 3 and a positive 2. Since my leading coefficient was 1, I could take that shortcut. So now I need to set each factor equal to 0. I have 3 factors, so I should have 3 solutions. This x out front gives us our x equals 0. Our second factor, x minus 3 equals 0 when x equals 3. And our third factor, x plus 2 equals 0 when x is negative 2. To be complete, we should check all 3. So, we can do this in the... We can't do this in the calculator, not if we want to do it the real way. So, let's do this one by hand. We won't check the other one by hand, but I will remind you that you do need to check these as you go. So, I first want to try 0. 0 cubed should equal 0 squared plus 6 times 0. This whole thing equals 0, that works out. How about our 3? 3 to the third should equal 3 squared plus 6 times 3. 3 to the third is 27, should equal 9 plus 18, which it does. And finally, 2 to the negative 2, my negative signs are terrible, should equal negative 2 squared plus 6 times negative 2. Negative 2 to the third power gives me a negative 8, which should equal a negative 2 squared gives me a positive 4, and then a 6 times negative 2 is a minus 12. 4 minus 12 equals negative 8, and we have correctly solved this equation. For the other one, again, I'm going to subtract the 4x from both sides, subtract the 28 from both sides, and I wind up with x cubed plus 7x squared minus 4x minus 28 equals 0. This one we can factor by grouping. So I'm going to look at the left-hand side and the right-hand side independently of one another and factor. So I can factor out an x squared, leaving me with an x plus 7. And over here I can factor out a negative 4, leaving me with an x plus 7. Don't forget the equal 0. So now to finish factoring this, my x plus 7 is my greatest common factor, and I have an x squared minus 4, and this equals 0. But remember, we have to check all of our binomials to make certain that we are done factoring, especially if I have coefficients that look similar, or if I have a quadratic as one of my factors. And x squared minus 4 does factor. This is a difference of two squares, so I'm looking for two things that multiply to negative 4 and add to 0. So give me an x plus 2 and an x minus 2. But don't forget your x plus 7. So again, I'm going to have three factors here, three solutions. X equals a negative 7, and also a plus or minus 4. This is completely appropriate. You may indeed collapse your two solutions into a plus or minus 4. We will do so quite frequently. Now I want to check these. I know I said we wouldn't, but I lied. We will. I'm going to plug in negative 7 cubed plus 7 times negative 7 squared should equal 4 times negative 7 plus 28. I'm also going to do negative 4 cubed plus 7 times negative 4 squared should equal 4 times negative 4 plus 28. And I will also try 4 cubed plus 7 times 4 squared should equal 4 times 4 plus 28. Let me try that again. And again, we'll get the calculator out to make this a little bit faster. So, negative 7 cubed plus 7 times negative 7 squared. This one gives me a 0. See what the other side says. 4 times negative 7 plus 28. Some of you are probably realizing already what this is going to give me. 0 equals 0. We're good to go. Let's go back to the calculator. Actually, I think I'll drag that screen over here. Try the next one. Negative 4 to the third power plus 7 times negative 4 squared. This gives me a 48. We certainly hope that we get a 48 out on the other side. 4 times negative 4 plus... Did I do that right? I did not do that right. Oh, what happened here? 4 times negative 4 plus 28. And I get a 12. Very strange. I wonder what happened here. So we will come back and we will check that one again. Let's check the last one just to see what happened. I'm very curious about that. Well, 4 to the third power plus 7. Oh, I see what happened. No, I don't. Plus 7 times 4 squared. It gives me 176, which was not going to equal this side. With a little bit more investigating, I again caught my error. This should have been a plus or minus 2. So when I'm checking these, I'm checking a plus or minus 2. So I'm going to erase the 4's, try this again with a plus or minus 2. So, go back to my calculator, figure this out. I'm going to check my negative 2 cubed plus 7 times negative 2 squared should equal 4 times negative 2 plus 28. And I'm also going to check 2 cubed plus 7 times 2 squared should equal 4 times 2 plus 28. Negative 2 to the third power plus 7 times negative 2 to the second power. I get a 20. And 4 times negative 2 plus 28 will give me a 20. And lastly, 2 to the third power plus 7 times 2 squared gives me a 36. And calculator, where'd it go? I will do drag this over here. The last one I'm going to do is 4 times 2 plus 28 should also give me my 36, which it does. And life is happy and wonderful, and we have found our error. Gotten very good at that today, finding my errors, which is helpful for you to see. How do you go about finding an error and fixing it? Before we do any more math, I want to talk about what the graphs of these will look like. We've graphed a quadratic, we've solved a quadratic, and we've solved a cubic. And we've seen that with a second degree polynomial we get out 2 roots, 2 zeros. And with a third degree polynomial we get out 3 roots, or 3 zeros. 3 solutions to the equation. So when I look at my graph of these functions, let's talk about an x-intercept. An x-intercept is where a graph crosses the x-axis. Y equals 0. So if I have a polynomial function, a y equals x squared plus 3x minus 2, for instance, I can find an x-intercept by setting this equal to 0. So what we've been doing algebraically, graphically, would be where each of these polynomial graphs crosses the x-axis. And really we can count roots. We can count places where this crosses. This has 2 distinct places where the graph crosses the x-intercept, the x-axis. And so we have one quadratic with 2 factors. So this function goes with this graph. What about this quadratic that only has one place where it crosses the x-axis? That would be where we only have one root, one solution, but it's a repeated solution. And something like this crosses the x-axis 3 times, one of which is at 0. So I'm looking for a function where I have one solution as a 0. Well, this equation would have x equals 0 be one of my solutions. And I have 1, 2, 3 solutions to this equation. So this must go with this graph. And by process of elimination, my g of x would go with this last graph that crosses 3 times, has 3 different roots, 2 of which are on equal distance from the y-axis. And so I can say that my g of x is this last graph. If you don't believe me, try it in your calculator. Plug these functions in just as you see them, see what your graph gets you.